Hello, my AP Pre-Calc friends. This is Mr. Bear, and I am going to go through the multiple choice questions of the benchmark study guide so that you can hear explanations to go along with the actual solutions to the questions, okay? All right, so let's go ahead and start with the first question here. We have this graph of a function, and it wants to know from point A to point B what is happening to this function, okay? So they are asking questions about whether the function is increasing or decreasing. So remember, for a function to be increasing, it has to have a positive slope, and for it to be decreasing, it has to have a negative slope. In this case, it's got a negative slope, so I can eliminate A and B right off the bat. So then, now that I know that it's got a decreasing or a negative slope, it's a decreasing function, we need to know if that's concave up or concave down. So remember, the way to remember that, concave up like a cup or down like a frown. Well, this section here clearly looks like it's concave up, so C is our answer for this one. All right, for the second question, it says, which of the following limit statements about the end behavior of this function is correct? All right, so let's first figure out what's going on here. So we have negative 2x times x squared times x to the third. All right, so what I'm trying to figure out here is the leading coefficient term. So I get negative 2x to the 1 plus 2 plus 3. That would be negative 2x to the 6. All right, so our leading coefficient is negative, okay? And when we see that, we automatically go to the right side of the graph and point downward, all right? So negative leading coefficient points down to the right. So that means the limit as x goes to infinity means it's going to go to negative infinity. So I know it can't be this one or this one. Now we look at the degree of this polynomial, and this polynomial has an even degree. So kind of the theme in this class is anything that involved even meant they did the same thing. So in this case, the left side is going to also go the same way as the right side. All right, so that means that on the left side, as x goes to negative infinity, our function also goes to negative infinity. So this is wrong, which means the answer has to be A. Okay, let's go ahead and look at this next one. We are given this function here, this rational function, and it says, which of the following things is going to be true about this? All right, since they're talking about holes, asymptotes, and all that good stuff, that means that we have to factor this thing. On top, we have 2x squared plus plus 1x minus 15. To factor this, we're going to take our a times our c, which will give me negative 30. And we need the two numbers that multiply to negative 30, but also add to the b value, which is 1. So you should be thinking 6 and negative 5. Now, Mr. Bear does a shortcut way to factor these. So if you're watching this from Miss Major's class and you're wondering what to do next, do whatever you do next. I just take the numbers that we got here and I divide by the a, which in this case is 2. So we get 3 for this, and this one doesn't simplify, so I'll write it as 2x minus 5. This one will be x plus 3. Okay, so now I know what my numerator will factor as. So x plus 3 and 2x minus 5. In my denominator, I have two numbers that multiply to a is 1, c is negative 21, so negative 21. And they have to add to negative 4. So that's going to be 7 and negative 3. This time my a is 1, so I really don't need to divide by 1, but I get x plus 7. And x minus 3. Okay. Oh, you know what? I just realized I factored that one wrong. It should have been negative 7 and positive 3. Okay. This is going to make a lot more sense in this problem. Let me fix those factors, and then we will actually answer the question. Okay, so sorry, that was x minus 7 and x plus 3. All right, so now that we see that, what we need to realize is that these terms cancel out, which means we must have a whole at x equals -3. So I can eliminate option A, and I can eliminate option C. So now it gets us down to B or D. Well, since x minus 7 is still left in the denominator and it doesn't cancel out, I can't have a whole at x equals 7, so D is now out. So B has to be our answer. All right, let's go ahead and look at the next one. This one, we have a piecewise function. It says what's the average rate of change on the interval from 1 to 5. So we treat that 1 as A and 5 as B. Our formula for average rate of change is f of B minus f of A over B minus A. Well, I'm going to replace the B and the A with the 5 and the 1. So probably should have just done that to begin with. All right, f of 5. So when x is 5, I must use this top row because it equals 5. So 4 minus 3 times 5. That's 4 minus 15, so -11. F of 1, I also use the top row, so 4 minus 3 times 1, so that's 4 minus 3, just 1. So we get -12 over 4, which is -3, so B. All right, let's continue on. Here we have a function, and we're supposed to tell which one of these things is true. So it looks like first I see linear versus quadratic. So let's first figure that out. We first check our inputs, and we can see that these are increasing by the same amount each time. So now we're going to check our outputs. From 1 to 11, we go up 10. 11 to 19, we go up 8. 19 to 25, go up 6. And then we go up 4. Well, those are not all the same, so I can rule out linear. And it's probably going to end up being quadratic. And that is true because those changes of the changes are the same. So notice that I just said that I took the changes of the changes, meaning I did this process twice. So part C, or option C, says the rate of change over consecutive equal length input values is constant. That's not true because we saw that those were different numbers. So that forces D to be our answer. And here it says the change in the rates of change are constant. Okay, next one here, we are given a graph of a function, and we're supposed to figure out which of these options it'll be. To do this, I'm going to first look at the far right side of my graph, and I see it points downward. That means I must have a negative leading coefficient. So looking at my answer choices, C and D are now eliminated. To figure out which of the two that it should be, I'm going to look now at my x-intercepts. This x-intercept is going to be a negative number, so it's going to have x plus something. And because it kind of does a U-turn or bounces off of that x-intercept, I know it must also have a multiplicity of 2. So I need x plus something squared. And if I look at my remaining answer choices, I see that option B has x plus something squared. So B is your answer. All right, for the next one, polynomial has this function, p of x equals x squared plus 4 times x squared minus 9. Which of the following describes the zeros of p? Well, I'm going to factor this again. X squared plus 4 doesn't factor, but x squared minus 9 factors as x plus 3 and x minus 3. And since x squared plus 4 doesn't factor, then what we do is we set these equal to 0. X squared plus 4 equals 0. Subtract 4 on both sides. Take the square root, and since I'm taking the square root of a negative number, I'm going to have plus or minus 2i. It's going to be imaginary. That right there tells me I have two non-real zeros. Okay, so looking at my answer choices, I can eliminate A, I can eliminate B, and I can eliminate C, which means it has to be D. And just so you know, the other distinct real zeros would be x equals -3 and x equals +3. That comes from the other two factors. All right, next one here. We're given f of x equals this function, x squared minus 5x plus 10. G of x equals 2x squared minus 3x minus 14. And we want to know, when is f of x greater than g of x? All right, I'm going to anticipate needing a little bit more room. So I'm going to erase this stuff I did up here just to give myself a little more room. First of all, when we see this, we immediately run into a problem. We don't want to have f of x greater than g of x. We want our inequality to have 0 on one of the sides. So what I'm going to do is I'm going to write this as f of x minus g of x is greater than 0. Okay, so essentially what I've done is I've subtracted g of x on both sides, and this allows the right side to now be 0. Since I know that now, I'm just going to take my f of x function, which is x squared minus 5x plus 10, and I'm going to subtract from it my g of x function, which is 2x squared minus 3x minus 14, and I need that to be greater than 0. All right, so we distribute that minus sign, and we get x squared minus 5x plus 10 minus 2x squared plus 3x plus 14. And I combine my like terms, so I get negative x squared minus 2x and plus 24 greater than 0. In order to then be able to make this nice and easy to factor, I'm going to factor out this negative. Or really what I'm going to do is I'm going to divide both sides by -1. And that gives me x squared plus 2x minus 24. Since I divided by a negative, I'm now going to change my inequality symbol. Instead of being greater than, it will now be less than 0. And then to be able to put this on my number line, I'm going to factor this and figure out my numbers. Two numbers that multiply to -24 but add to 2 will be x minus 2, or no, x minus 4 and x plus 6. Okay? So then my numbers that go on the number line are x equals 4 and x equals -6. Also, since I know those are the numbers that will go on my number line, I can eliminate D as an answer choice, and I can eliminate B as an answer choice. That's nice. All right, so now I'm going to put my numbers on my number line, -6 and 4. Inequality is just less than, so not equal to, so I'm going to have open circles. Not that it matters in this problem because everything is written as a parenthesis instead of a bracket, so don't even have to worry about whether they're open or closed. All right, let's go ahead and pick our test numbers. So I'm going to pick -7, I'm going to pick 0, and I'm going to pick, 5. I have two factors to check them in. So let's see, -7 minus 4 is clearly a negative. -7 plus 6 will also be a negative. And when you multiply two negatives, you get a positive. We need our inequality to be less than 0, so that interval doesn't work, which means A isn't the answer. It's going to have to be C. All right. By the way, if you wanted, you could have also just picked an x value in each of these intervals, plugged them into your f and g of x if that helps you, like if you're struggling with time. But anyway, let's look at this next one. F and g are polynomials. Here's f of x, here's g of x. H is the rational function where your f of x function is on top and g of x is on the bottom. We want to know which of the following is a slant asymptote. Well, hopefully you understand why it's a slant asymptote, because the degree of f of x is 2 and the degree of g of x is 1. Degree on top is higher, so therefore it must be not a horizontal asymptote. All right, so then to figure this out, I'm going to need some room again. So I'm going to just erase what I did up here. Don't worry, the full key should still be posted on Google Classroom so you can see all of this, but I need room to write because this video is more about explaining the work. All right, so let's see. I need to take the -2x squared plus 3x minus 8, and I'm going to divide by x plus 3. If you're watching this from Miss Major's class, you might look at this and think, I don't do this method to solve this. And that is okay. You do what works for you. My students, I taught it this way to them. All right, we're trying to get to negative 2x squared. So I'm going to put that in this upper box. And then I'm going to ask myself, what did I multiply to x to get negative 2x squared? The answer to that would be negative 2x. Now I can fill in this bottom box here by taking 3 times negative 2x, and that gives me negative 6x. Okay? All right, by the way, since I know that I have a negative 2x here, and I look at my answer choices, I know D is now out. Okay, so this next part, pay close attention, especially if you still struggle with this. I need to get to 3x's. I have negative 6x's right now. So I need to add 9x to the negative 6x so that I combined have 3x. All right, and so what that means is that x times 9 gives me 9x. And so this becomes the equation that I need to have. So C is our answer. All right, I'm going to do this question here, and then this will be it for part 1. I'll make a second part to help with the rest of the video, or the rest of the study guide. All right, so for number 10, it says that we have a polynomial function f, and we have some different values for x. What is the least possible degree of f? First thing I notice is that my x values are increasing by the same amount each time. So we do have equal length inputs. So now to figure out the least degree, we do those rates of change of the outputs until we see a constant situation. All right, so to go from 2 to 2, I go up by 0. From 2 to 3, I go 1. 3 to 5, 2. 5 to 8, 3. And right there I can see, oh, that is not going to be a degree of 1. So A is out. Now I check to see how my changes change. And I'm increasing by 1 each time on that. So that's constant. So that means since I did 2 changes, I have a degree of 2. All right, I'm going to stop this video at this point. I'll have a part 2 for the remaining questions.